Guys, I'm glad to see you again on my channel, and today we'll check another exercise which is called removenthnodefromend. It's medium type level. So let's check what we are given. So we have a head of a single linked list and an integer n. We need to remove the nth node from the end of the list and return its head. We'll have an example where we have initially one linked list with values 1, 2, 3, 4, 5, and n is equal to 2, which means that we want to remove this element because we count from the end 1, 2, it means that we want to remove 3, and in the end we will have a linked list with nodes with values 1, 2, 5 and null. So I hope it's clear. Now let's visualize how this algorithm is working and what actually we need to implement through the code. So let's imagine that we have this linked list, and initially we create a dummy variable, because when we will iterate, we want to start from this element. This element will be on the first iteration, this on the second iteration, so on. Also, dummy will store the link address to the beginning of our head, to the beginning of our list. Also, we will have two variables, slow and fast pointers. If you don't know what does it mean, I really suggest you to check the previous exercise because we also use them there and it will help you better understand this task. But if you haven't watched the previous videos, so what is the idea? So initially we will have a pointer which is called, let's say, fast. Fast, and we will use this pointer. Initially both will point to the same address, to the address of a dummy pointer, and when we will start to iterate, we will start from the first node of our linked list. And what is the idea? So we will iterate n times. Why so? Because when we will stop to iterate, we will have a distance. For example, if n is equal to 2, it means that distance between slow and fast will be 2. And then we will start to iterate both pointers, and when we will reach the end of this linked list, we will have distance of 2, which will allow us to change to omit the second node, but we will see it a little bit later. So we have these two pointers, slow and fast. Initially they both points to the header, and we start our iteration. So in my case n is equal to 2, so I will need to move my fast pointer to 2 steps. So in the first iteration, fast will point to 1, its first iteration, and on the second iteration it will point to 2. And here we stop our iteration only for fast and start to iterate also slow and fast in the same time. So you can see how does it work. So we move fast on 1 step and slow also on 1 step. So you can see that slow pointed to dummy, now it points to the next element. And we are doing so until we reach the end of our list. So you can see that now fast points to 4, but slow points to 2. Fast points to 5, slow points to 3. And here we have this distance of 2, 1, 2, which means that now we want to take element to which slow is pointing and to change the address to the next element to point not to this node but to this node to which so to the next pointer, because it will be the slow.next node pointer. So 3 will point not to the 4 but to the 5, and like this we will omit the second element. And using this technique, we will be able to solve this exercise. So I hope it's clear, and let's take a look how we can implement this through the code. So let's create the signature of our method. So public static. We will return the node. And let's call our method remove from end, and like argument we will have the head of linked list, from where we want to remove the nth element from the end, and an element. Okay, perfect. Now let's create the dummy. The value actually is not important, but let it be 0. And the next element will point to the head of the current linked list. Now let's create two variables. One will be slow, and it will point to dummy, and fast, which also initially will point to dummy. Okay, perfect. And now let's first we need to iterate fast pointer n times. Okay, so let's create for loop. Here we'll declare I, which is initially equal to 0. I is less or equal to n, and I++. Okay, perfect. Actually here should be just like this, and fast is equal to fast.next. Okay. No, actually here will be equal because we start from the dummy but not from the head. Okay, so the next step, we need to iterate both fast and slow pointers, and here we will put a condition that we want to iterate while fast is not equal to 0. Actually it's null. And here we need to increase each pointer to one step. Next node, and fast is equal to fast next node. Okay, and when we will finish our iteration, we just need to change the pointer of the next element for slow, the pointer to element to which slow indicates, to actually like this, slow is equal to slow.next node, and actually not, it's not correct, next node, and here will be next node. And in the end we will return the head of our linked list, which is equal to dummy.next node. So that's the solution. I hope it was clear, and we will see in the next video. Bye.